and we see much more nickel than iron, which is very unusual and maybe implies industrial production of nickel.
It starts with impact level shock, not discovery. The numbers arrive on astronomers' screens, and within seconds, something feels wrong. Not unusual, wrong. 3I Atlas is already inside the solar system, already moving fast, already past the point where clean explanations usually exist. Its orbital solution locks in, and the room goes quiet. This is not a path objects are supposed to take. The trajectory cuts almost directly against the ecliptic plane, nearly anti-aligned with the flat disk where planets, comets, and debris normally travel. Statistically, it borders on impossible. No survey forecasted it. No simulation hinted at it. Stellar ejection models don't produce this geometry. Not often. Not cleanly. Not like this. The orbit doesn't just break expectations, it ignores them. As refinements come in, a deeper problem emerges. The object's path is indifferent to every gravitational alignment astronomers expect from natural interstellar debris. It doesn't trace back to a parent star. It doesn't line up with galactic tides. It enters as if dropped from nowhere, threaded through the solar system at an angle that refuses to explain itself. Then comes the detail that tightens every jaw in the room. Attempt of 3I Atlas does not threaten Earth, yet it passes close enough to matter. It skims planetary hill spheres, the gravitational borders where objects are usually pulled, bent, or disrupted. Jupiter, Mars, even Earth's region. But each time, the object avoids deep interaction. Not wide misses, precise ones, close enough to be altered, far enough to remain untouched. At first, scientists tell themselves this is coincidence. Random trajectories can look intentional after the fact, but the math keeps closing in. The avoidance is too clean, the margins too narrow. Monte Carlo simulations fail to reproduce the pattern. When randomness is forced into the model, the path collapses. When selectivity is allowed, the data suddenly fits. That's when the warning sign becomes impossible to ignore. No prediction model accounted for this orbit, not because the model was weak, but because nothing like this was ever included. The absence itself becomes evidence. The object is not violating one rule. It is operating outside the rulebook entirely. And that realization lands like a delayed shockwave. Debate erupts across observatories and institutes. Some argue this is statistical overreach. Others push back harder. If gravity alone can't close the gap, something else must be shaping the motion. But no one can point to a force that fits without opening new, uncomfortable questions. Each attempt to explain the path leaves residue, small errors that don't go away. The most unsettling conclusion arrives quietly. The orbit does not point back to a star. It does not point to chaos. It points to uncertainty, structured, persistent, unresolved. Something passed through the solar system without announcing itself, without fitting expectations, without leaving a clean origin behind. And just as scientists begin to ask whether motion alone is the message, new data surfaces, this time not about where 3I Atlas is going, but what it's made of. The shock does not come from the orbit this time. It comes from the chemistry. Buried deep inside routine spectroscopic scans, a signal appears that should not exist. At first, it looks harmless, just another faint line among thousands. But when astrophysicists isolate it, the room goes quiet. The element is unmistakable. Nickel. Not mixed, not bonded, not alloyed. Nickel, alone. In every known natural process, nickel travels with iron. They are born together in stars, forged together in explosions, scattered together through space. Separating them requires immense control, precision, intent. Yet 3I Atlas carries nickel without iron, cleanly and consistently across repeated observations. That single fact detonates decades of planetary science. researchers immediately assume error. Instruments are recalibrated, data pipelines are rerun, independent observatories are asked to verify the reading, different telescopes, different teams, different continents. The result does not change. Nickel persists. Iron does not appear. Databases are opened in a panic. Every comet ever studied, every asteroid spectrum on record, every interstellar visitor, nothing matches, not even remotely. There are no analogs, no footnotes, no exceptions buried in old journals. The signal stands alone. Then comes the comparison no one wants to make, but no one can avoid. On Earth, there is exactly one known process that separates nickel this cleanly. Not geology, not volcanism, not stellar physics, industry. The carbonyl process used in modern metallurgy to refine nickel for high-performance alloys, a method designed by intelligent systems to extract a single element with surgical accuracy. This is not vague chemistry. This is method-specific residue. The implication hits harder than the orbit ever did. If astronomers saw artificial light blinking on an exoplanet, they would not call it noise. They would call it technology. The nickel signal carries the same weight. It is not dramatic because it is bright. It is terrifying because it is precise. And precision does not happen by accident. Some attempt to slow the panic. They suggest unknown cosmic processes, exotic reactions, rare interstellar chemistry never before observed. But every proposal collapses under the same problem. Nature is messy. What appears in space is always mixed, always chaotic, always accompanied by collateral elements. 3I Atlas is not messy. The nickel signal is narrow, stable, repeating. It behaves like a fingerprint, not debris. Worse still, it arrives quietly. There is no explosion, no flare, no visual drama. The danger lies in how easy it is to miss. Had one filter been adjusted differently, had one threshold been set slightly higher, the signal would have vanished into background noise. That realization terrifies scientists more than the signal itself. How many other objects passed unnoticed? Internal discussions grow tense, language changes. Words like unlikely and anomalous give way to unexplained and non-natural. Emails are rewritten, draft papers stall. No one wants to be the first to say the obvious thing out loud, because once said, it cannot be taken back. No comet, no asteroid, no interstellar fragment in recorded history has ever carried this signature. The object is not just chemically strange, it is selectively strange, and that shifts the question permanently. The debate no longer centers on what 3I Atlas is made of. That question has reached a dead end. A far more dangerous one takes its place. Who or what would leave a chemical footprint like this in interstellar space? And before anyone can answer, a deeper concern begins to surface in the data, one that suggests the nickel may not be the only signal hiding in plain sight. Because if this anomaly was never predicted, what else are scientists about to realize they failed to look for? The warning does not come from what scientists predicted. It comes from what they didn't. Almost immediately after the first anomalies of 3I Atlas surface, a familiar defense rises inside the scientific community. Critics point to one argument again and again. None of this was forecast. No model predicted this orbit. No simulation expected these signals. No paper warned of this behavior. Therefore, they argue, the concern must be exaggerated. But that argument begins to collapse the moment it is examined. Veteran researchers quietly remind their peers of an uncomfortable truth. Some of the most important discoveries in astronomy were never predicted either. Hot Jupiters, giant planets orbiting dangerously close to their stars, were once considered impossible. Their discovery didn't just surprise scientists, it forced entire theories of planetary formation to be rewritten. Pulsars were first detected as unexplained radio pulses and briefly labeled LGM for little green men, because nothing natural seemed to fit. Even cosmic acceleration was missed until it was suddenly undeniable. None of these phenomena were forecast. All of them changed science forever. An anomaly, by definition, does not send an invitation. As this historical parallel resurfaces, the debate around 3I Atlas begins to shift. It is no longer only about orbital mechanics or spectroscopy, it turns philosophical. And that is when unease spreads through the room. Because the question underneath the argument is far more dangerous than it appears. If science demands prediction before attention, what happens to the unknown? Some researchers begin to realize that insisting on forecasts before accepting anomalies creates a silent filter. Only the expected survives scrutiny. Only the familiar receives funding, telescope time, and peer approval. Anything that arrives outside prepared categories is quietly dismissed, not because it lacks evidence, but because it violates comfort. That realization hits hard. Demanding prediction does not protect science from error. It protects science from surprise. Inside closed meetings and late-night calls, investigators start using a different analogy. Ignoring 3I Atlas because it was unpredicted is like walking past a crime scene because the suspect wasn't on a watch list. The clues are still there. The pattern still exists. The consequences don't vanish just because no one expected them. And the data itself offers no reassurance. The orbital calculations do not soften with debate. The chemical signatures do not adjust to consensus. The non-gravitational accelerations remain measurable. Each update arrives cold, indifferent, and exact. The object does not respond to disbelief. It does not wait for philosophical agreement. The data does not care about precedent. That indifference becomes the most unsettling part of all. Because when scientists strip away expectation, tradition, and bias, what remains is a simple and terrifying fact. Something is occurring outside the boundaries of preparation. Not just outside prediction, but outside the frameworks designed to detect it early. And that is precisely why it matters. Late-stage reviews now reveal an even deeper problem. Many monitoring systems were never optimized to flag objects like 3I Atlas. Filters were designed to ignore statistical outliers. Algorithms were trained to smooth irregularities. The very tools meant to protect against false alarms may have delayed recognition of a real one. The realization spreads quietly, then all at once. The lack of forecast is no longer a dismissal, it is the alarm itself. Because whatever 3I Atlas represents, it arrived without permission, without warning, and without fitting into any prepared narrative. And history shows that moments like this, moments that appear unannounced, are exactly when understanding either leaps forward or fails completely. As the discussion reaches this point, the room goes silent. The next question hangs in the air, unanswered and unavoidable. If prediction failed, what else are the models failing to see right now? And worse, what happens if the object isn't just anomalous, but adaptive? That question does not belong to this part of the story, but it is already waiting in the next. The alarm doesn't come from proof, it comes from failure. Inside observatories and analysis rooms, skeptics raise a familiar warning. The technological hypothesis is too flexible. It can explain too much. It bends around objections. It refuses to snap. And that, they argue, makes it dangerous. But the warning backfires, because flexibility cuts both ways. If 3I Atlas were behaving like a normal comet, it would fit somewhere, anywhere, inside known physical boxes, but it doesn't. Every attempt to lock it into a natural category leaves something behind. A leftover, a contradiction that refuses to go quiet. Teams try dust-driven jets. The math almost works until it doesn't. The jets appear at angles that violate thermal models, firing where sunlight shouldn't be able to drive activity. Some jets emerge from regions that should be cold, inactive, dead. Others switch on and off without warning, as if responding to changing conditions rather than internal pressure. That is not how comets behave. Trajectory models are recalculated again and again. Non-gravitational forces are added. Solar radiation pressure is adjusted. Outgassing coefficients are stretched to their limits. Each tweak saves one anomaly while creating two more. The object doesn't drift like debris. It corrects. Small changes in velocity appear timed, not continuous. Not the smooth decay expected from passive material, but sharp adjustments that look reactive. As if something notices the environment and responds, as if motion is being managed, not merely endured. Scientists hate that thought. Not because it sounds impossible, but because the data refuses to reject it. Every natural explanation fails in a slightly different way. No single model collapses completely, but none survive intact either. The failures stack. The gaps align. The exclusions stop working. That's when the fear changes shape. It's no longer about finding the right answer. It's about realizing how many answers don't work. The object resists classification at every layer of observation. Orbital dynamics don't match. Chemical signatures don't align. Jet behavior defies expectation. Even its brightness fluctuations refuse to follow known patterns. Each dataset looks survivable in isolation. Together, they form something worse, a pattern of resistance. Not resistance to detection, but resistance to explanation. Quietly, reluctantly, researchers begin to admit something unsettling. Ruling out technology is becoming harder than living with uncertainty. Not because technology is proven, but because nothing else survives contact with the evidence. This is the flexibility trap. If the hypothesis were rigid, it could be shattered, but it isn't. It stays standing not through belief, but through elimination. Every door slammed shut on natural causes leaves one door still open, narrow, uncomfortable, but unlocked. And that terrifies people, because science is built to expand knowledge, not to confront intent. Tools can measure mass, velocity, chemistry. They cannot easily measure purpose. Yet 3i Atlas behaves as if purpose is leaking through the cracks subtly, indirectly, deniably. No one claims certainty, no one announces conclusions, but the conversations change tone. Words like unlikely and implausible are replaced with not excluded. Meetings run longer. Silence stretches between sentences. The question is no longer asked out loud, but everyone feels it forming. What if the hypothesis survives because it should? The object continues moving, data continues arriving, and with every new observation, the box meant to contain 3i Atlas grows weaker. The hypothesis remains standing, not because it's accepted, but because nothing has been able to push it down. And as scientists prepare to argue whether flexibility is a flaw or a warning sign, a new realization begins to spread. If this object is reacting, adapting, or choosing, then the next phase isn't about what it is. It's about what it does next. The standoff ignites without warning. What began as quiet disagreement inside research groups spills into public view, and the tone shifts from cautious analysis to open confrontation. Press briefings tighten. Language hardens. One faction of scientists demands strict testable predictions before even acknowledging the anomaly as worthy of attention. Without forecasts, they argue, there is nothing to test and therefore nothing to discuss. To them, engaging 3i Atlas beyond standard models risks contaminating science with speculation. Their stance is framed as discipline, but beneath it, others sense fear. Across the divide, another group pushes back with growing urgency. They warn that demanding prediction before understanding reverses the scientific method itself. No theory predicted quantum mechanics. No equations forecasted hot Jupiters. Discovery has always arrived first, explanation second. They argue that insisting on forecasts now is not rigor, but authority protecting itself. If science refuses to look unless it already knows what it expects to see, then it blinds itself by design. The tension spikes as this accusation lands, that modern science may be filtering out the unknown to avoid embarrassment. The debate fractures the community in real time. Conferences turn tense. Papers are delayed. Language in journals becomes cautious to the point of paralysis. Behind closed doors, researchers admit the fear no one wants to say aloud, that engaging the anomaly could end careers if it collapses, or rewrite fields if it doesn't. The argument is no longer about 3I Atlas alone. It is about power, reputation, and whether surprise still has a place in a system built on certainty. Observers outside the field feel it too. This is not an academic disagreement, it is a moment that will define how discovery happens from this point forward. Then something unsettling happens. After the loudest arguments, the room goes quiet. No consensus emerges, no resolution follows, just silence. Heavy, unresolved, and charged. The object continues its silent passage through space while humanity debates rules instead of signals. And as the standoff lingers, a more dangerous realization begins to spread. While scientists argue over how to look, the opportunity to look at all may already be slipping away, because 3I Atlas is moving on and the window to act is closing fast. It is already slipping away. While committees debate language and journals argue thresholds, 3I Atlas keeps moving, indifferent to hesitation. Its velocity relative to the sun is increasing, its angle drifting beyond the range where fine-grained measurements remain possible. Telescopes can still see it, but seeing is no longer the same as understanding. The window where weak forces, subtle thrusts, or internal structure could be resolved is narrowing by the hour. There will be no guaranteed second chance. Interstellar visitors do not orbit back. They pass once, cut through the system, and vanish into deep space. Unlike planets or comets bound to the sun, 3I Atlas is not obligated to return. Its trajectory already points outward. If this moment is missed, it may never be observed again by any generation. Scientists understand the implication with growing unease. If the object possesses propulsion, however weak, it would only be detectable now, while solar radiation pressure, outgassing models, and gravitational influences can still be cleanly separated. Once distance increases, everything blurs, signals collapse into ambiguity. What looks like noise later could have been clarity today. Delay is no longer neutral. Every hour that passes strips away resolution. Spectral lines flatten. Temporal correlations disappear. Fine deviations in motion fall below detection thresholds. What remains will be averages, safe, smooth, explainable. And averages are where anomalies go to die. This is the part no one says out loud. If 3I Atlas is natural, delayed observation will eventually make it look natural. If it is not, delay will erase the fingerprints. The universe does not preserve evidence for convenience. It moves on. Inside observatories, the mood has shifted. The arguments are quieter now, less philosophical, more urgent. Some researchers push for emergency observation time. Others hesitate, aware of reputational risk. No one wants to be wrong first, yet the greater fear is emerging beneath the surface, being silent during the only moment that mattered. History offers no comfort. Past discoveries that reshape science were often recognized late, but never this late. Never with a single pass. Never with the clock this visible. This is not a slow-burning mystery. This is a countdown. The final tension tightens. Discovery does not wait for consensus. Nature does not pause while humans argue definitions. Whatever 3-eye atlas is, an extreme natural outlier, a statistical miracle, or something else entirely, it is unfolding now, not later, not after review cycles, not after comfort returns. And as the object fades toward the edge of detection, one question hangs unresolved, growing heavier with every lost hour. What if the next anomaly doesn't arrive quietly? And what if this was the warning pass?